Hello, so today we're starting exercise 3G. In this one, part 1, we're talking about cubics and polynomials. And we are going to go into polynomials more in a moment, but just to remind you, polynomials are things where we've got like x cubed take 3x plus 1, or we might have x to the 7 take x to the 17 plus 3 million, or we might have x to the 2 minus x to the 9 plus x, something like that. But if we've got something like root x in it, or if we have something like 1 over x in it, which is x to the minus 1, remember, that's not a polynomial. Now, quadratics are types of polynomials, as well as linear relationships. Just to remind you, linear relationships, if we've got y equals mx plus b, well, there's definitely no square roots of x in there, and there's definitely no negative powers, so x isn't at the bottom of a fraction. And for quadratics, we had y equals ax squared plus bx plus c. And there we definitely don't have any square roots, no negative powers of x or anything. So they're different examples of quadratics, of polynomials. The type of polynomial we're going to be focusing on at the start of this kind of exercise is cubics. So for example, if I had y equals x squared, and no, not squared, cubed. So cube to the 3, because it's in 3 dimensions. So if I wanted to graph that, I would create a table of values for x and y, and maybe I'd want to start off at x equals minus 3, minus 2, minus 1, 0, 1, 2, 3. Something like that. So minus 3 cubed is negative 27. Minus 2 cubed is negative 8. Minus 1 cubed is negative 1. 0 cubed is 0. 1. 2 cubed is 8. 3 cubed is 27. So it kind of climbs really quickly, as you can see. And you can also see that if you're putting a negative value of x in, it stays negative. Unlike quadratics where it like squared, so go to the negative, this one doesn't. So here's my 0 and 0. Here's my 1 and 1, and here's my 1 and negative 1. 2 and 8, well, I'm going to have to move this whole thing. I don't want to take that down with it. There we go. I'm going to have to move this whole thing down to be able to fit in up to 8. 1, 2, 3, 4, 5, 6, 7, oh, right at the top. And negative 2 and negative 8. 1, 2, 3, 4, 5, 6, 7, 8. So you can see it's going to look like that. That's a really bad drawing. Let me do it on GeoGebra. So I've got y equals x to the 3. Let's draw that. So that looks like this. So you can see that it graphs it, like it climbs really quickly. And if I want to change my axis, maybe I want my x minimum, I'm just going to do to minus 4. Oh, come on. Okay, I'm giving up on that idea. This did not work. Let's try again. So, I want my x minimum to be minus 4 and my x maximum to be positive 4. My y minimum, well, 4 cubed is 4 times 4 is 16 times 4 is 64, so negative 64. Y maximum is going to be positive 64. To get rid of that. Okay, so now I want to put in y equals x cubed. And that's what it looks like. Don't forget, this looks kind of flat because the y-axis is a lot more squished in than the x-axis. And now let's look at what happens if we have a number out the front of that x cubed. So maybe I'll do y equals 3 x cubed. So that makes it even steeper. And maybe I also want to do y equals, I don't know, a quarter, 0.25 x cubed. So that gets kind of steeper. So if we go back to like a normal minus 10 and positive 10, and this one minus 10 and positive 10, we can see that the red one, which is the one with a number in front of the x cubed that's bigger than 1, it's like 3x cubed, that's a lot steeper than the green one, which is our x cubed, and the orange one, which is the one with a smaller than 1 number, so a quarter x cubed, is a lot shallower. Let's see what happens when we get really close to 1 though. Why is this not giving me axes? I don't know, they get squished down, that's all. Later on we're going to learn different transformations of this form, but I just want to take a photo of this and put it in our notes. Wow, nothing's liking me today. What's going on? I'm going to eat my soup. I made a soup last night and I ran out of stock cubes, beef stock cubes, so I put Vegemite in it instead, and it's worked actually really well. So let's add in this photo. Let's put it here. Okay. One handy thing about polynomials, and I'm going to remind you of some stuff with quadratics. That's me slurping my soup. So quadratics in factored form. Let's pretend we've got the function f of x equals x plus 3 x take 1. From our work in quadratics, you know that that's going to cross over the x-axis at exactly -3 and +1. And today I'm not going to care about where it turns around or where it intercepts. I know we can find that. One handy thing about cubics, and in fact all polynomials as you're going to find out, is if we're presented with a cubic in a factored fat form, let's say we had f of x equals, well, x plus 3, x take 1, x take 4. Or something. And I don't even know what that expands out to. If I wanted, I could do, you know, that times that. So that would give me x squared plus 2x take 3 times x take 4. Expand that out. X cubed take 4x squared plus 2x squared take 8x take 3x plus 12, which gives me x cubed take 2x squared take 11x plus 12. That's actually really irrelevant. You're never given them like that. What you'll always get is them in this factored form. And we can actually sketch them with a fair idea of what they're going to look like if we've got them in factored form. I'm going to show you on here what it should look like, and then I'll show you on GeoGebra that it actually does look like that. So if this is my y, and this is my x, I don't know why I did this all the way over to the left. There we go. Now, now it lines up. I know that it's going to go through the point x minus 3, plus 1, and plus 4. And I know because my normal quadratics always start at the bottom left and go up at the top right, that it's going to start here. At some point it's going to turn around, not necessarily halfway between, and it's going to go through this one on its way back down, and it's going to go up here. Later on when we do calculus, you're going to be able to find these points where it turns around, but this is not that day. It's not actually really hard, but you've got to have some calculus skills to do it. So that's what it's going to look like. And this is -3, +1 and +4. Let's prove that to ourselves by doing it on here. I'm just going to restart this. So if I have y equals, in brackets, x, we had x plus 3, x take 1. See, that's the quadratic we'd started with, but we're also timesing it by x take 4. Oh, wow. So I hadn't predicted that it would jump up quite that high, but I didn't actually need to. In this course so far, you're not expected to figure out how far up it'll jump, just the fact that it's going to turn about at, oh gosh, that's gotten really weird. It's going to go through the x-axis at -3, +1, and +4. Let's do another example just for good luck. F of x equals x plus 5, x take, not take anything, let's just do x, which is x take 0, by the way, and x plus 3. No, not x plus 3, x take 3. So this one's going to go through our axes. I don't actually care whereabouts it turns around. It's going to start at the bottom left, it's going to start below the axis, and it's going to go through x equals -5, x equals, hang on, is that -3, 4, 5, yep. X equals 0, this one means x equals 0, and x plus 3. So it's going to turn around at those points. That's it. I'm going to go through doing the similar thing with harder looking ones and with like more generic polynomials in the next video.